Sometimes the formula F equals Kx, you'll see a negative sign, and sometimes you won't. The reason for that is if there's a negative sign, the F in the formula F equals Kx is the force of the spring. And since when you go to stretch it, the spring is forcing this way, right? While the displacement or distance is this way, the movement's this way. And for that reason, sometimes you see a negative sign. If you are doing the force that it's you, what force do you have to apply the spring on the spring? Then that force is in the same direction of the displacement, and so you don't have to, then it's just positive because there's no opposite direction of the force. All right, and then we see also there's the formula for the potential energy, which is 1/2 kx squared. And so realize if you stretch a spring twice as far, it's going to have 4 times the energy. So that's an interesting correlation there too. Okay, so our goal today is to find the K of the spring. All right, so the K, I sometimes say, is the springiness of the spring, or then how much force it takes to stretch a spring. It tells you how much force it takes to stretch a spring a certain amount. The higher the K value, the greater force necessary to do the same stretch, okay? So, per centimeter or whatever your unit is. All right, so what I have done already, so there are 2 springs for your lab, and so they are marked, and this one is marked A6 because I'm at table number 6, and I know it's amazing, but the other one is marked B6 because this is the second spring you're gonna do. And then the other thing that is here is also your unknown mass that we're gonna use. So once we find the K value of the spring, we can reverse things, and now our spring, since you know how much force it takes to stretch it a certain amount, then we can use the spring as a scale, actually, a spring scale. So we're going to be able to find the mass of an unknown as long as our K value is okay. So we're gonna work at discovering that K value. What I've done already is adjust this ring stand so the little pointer that's attached to the spring lines up really well with 0. I'm gonna start to zoom in here. So, and hopefully, oh, see that's moved a little. I wanna make sure the pointer's actually pointing for you. Okay, and then it's focused. It's pretty good there. All right, so, oh, look, we have announcements.
Good morning, Dreadnoughts, and happy Monday. It's great to have you all back in the building. It is time for the pledge. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Thanks, Dreadnoughts. Have a great day.
Look, you're getting the full experience of being in school. All right, so you see the pointer, and I'm trying to make sure, though, you can read the centimeter scale. And you see I did a pretty good job of making it read on 0 right now. So, okay, so no stretch for no force added. And so now we're going to add, and if you read the lab, it says add a 20-gram mass and record the distance stretched X. So I'm going to start, and there's a reason this one, right, why I said not to use, see the 10? This is 10 hanging from it. And yeah, exactly. So that doesn't really work out too well for us. So I'm going to hang 20 from it. So I'll let you see, there it is hanging, and it's doing a little bouncy bounce. All right, I'm going to zoom in here. Here, I'm going to try to calm it. Got my little hand underneath trying to stop it from oscillating there. That's another lab you can actually do with springs is see the oscillation. Then I moved the little pointer so that you can see. And because I made this pretty level, right, we should be able to read that quite well. Okay, so that is 20 grams hanging from it, okay? And you need to record your data right there as well as you can on how much, all right? And realize that 20 grams, right, we eventually need this to be in kilograms. And record that distance stretched and realize that that's a ruler in centimeters. So these are centimeters on this side, okay, that you should be looking at. And so there we go. Okay, so now, all right, you're gonna see, what am I gonna do? Well, I'm gonna go, it says to go by 20 gram increments, so I'm gonna do what I can. And so now I'm gonna grab another 20, all right, and hang it together, okay? And then we'll zoom in again. Okay, I'll try to stop the little bouncing. Okay, record that. Now I have to move to 60, and so I'm not gonna hang a third, but I have a 50, so I'm gonna put those back. I'm gonna get out a 50, I gotta make sure, 50, and a little 10. All right, you know what, I'm gonna rotate this so we don't have that nice back wall anymore. So I'm gonna hold my paper. Watch this. Oh, is that helpful, huh? Okay, I also, you know what though? My camera isn't quite as aligned. I'm gonna drop my camera down a little to make sure you stay at eye level, because you can get that little bit of parallax, right? Where if you look at an angle that you see something different. Okay, so I'm gonna try to keep every time, you know, at eye level on this. All right, sorry for the bouncy. Let's see if I can. I can't see to stop it. We're gonna wait here forever. Okay, I don't know. Okay, all right, well there's your error factor right there, right? Okay. Okay. By the way, when you're gonna be graphing this data as well, and you're gonna see when there isn't a lot of force, that you kind of have to settle into that spring constant. Oh, look at my math was so bad. I put those away, but I need to put that back. So I had my 60, right? And then I'm gonna add another 20 there. So I got a cute little mix going on right there. Okay. My paper again, hold on, I gotta write that. I got 80 now, right? Put my paper behind there. I'm still trying to make sure. I'm gonna lower, hold on, sorry. I'm gonna lower it just a little bit, trying to keep things fair. Okay, I'm gonna try to stop the bouncing. Ugh. Okay. Oh, I did a better job that time. Okay. All right, but again, as you graph it, you're gonna, or when you solve for your Ks, you're gonna see that it's gonna start to settle in. Okay, so now I got 80, so now I'm just gonna go to 100, so I get to pull those off, right? And I just put 100 on here now, okay? All right, I have to drop the camera again. Okay. Hold on, stop the bouncing. Okay, I'm checking. Yeah, it's pretty good. Of course, my phone has got those 3 little cameras, so that I don't know like which one is really at level, but okay. It's 100. Okay. So now I'm going to, just so you know, I'm not cheating. I'm gonna add, all right, the little 20. So I have to drop that a little. Make sure. Okay, that was hard to read again, so I don't know what I keep doing that. Sometimes you can read this and other times you can't, but there we go. Let me stop the bouncing. Here, I'll turn it so you get the little pointer. Isn't that sweet? They were really thinking, weren't they, with those little pointers? Except for, let's see if I can stop the bounce. Okay. All right, and we're gonna try to get as much data as we can, okay? I got another 20 I can throw on there. The second spring we're gonna see, depends on what your second spring is. Sometimes, everyone's got different springs for the lab for the second spring. And so what happens, checking my eye level, stop my bouncy bounce, but we may have to like alter some things when we do our second spring. We may not be able to go by 20s. Depends how lucky you are. Here, should I rotate a little so we can see better? Okay. All right. It's going to be an hour lab if we wait completely for the final bounce. Okay, wait. What we had 140. Okay, so 160. I'm going to have to go back and get my 50. All right, and my 10. So I got 100. Here, so you can see what I'm doing. I got 100, a 50, and a 10. Okay, but I still have to drop my camera a bit again. Check in levelness. Oh, let me scoot that. There we go. Okay. Let me stop the motion. All right, I'm gonna let you call it. All right, and now I need 180. What am I gonna do? Let me just throw another 20 on there. Oh, whoopsie. Yeah, this gets interesting now. Okay, drop this again. Oh, whoops. Well, maybe I even do need it there. Okay, let me help you out a bit. All right, we got it. All right, let me check one more time. Make sure I got it. Yeah. Okay, so now the magical 200. So I need a 100 and a 100. Is this another 100? Yes, okay. So you can see again. Two biggies on there. Stop the bouncy bounce. Oop, drop the camera. My paper behind there. All right. Okay. So now you have to change your mass into a force. So in other words, weight, right? M times G, we know how to do that. Don't forget, we don't like grams. And then you're going to find, solve for your K value using F equals KX. All right, then, and if there seems to be any real discrepancy, you can go back and, oh, no, I guess you can't go back and check. We're gonna assume Ms. Jones did everything great, all right? All right, so that is trial one. Move you back up here in this world a bit. And so now we're gonna replace spring A with spring B, okay? Hang that there. Now this one, right, it's a different length, so watch what I have to do, right? Do you see it's not pointing at 0? So I'm gonna have to adjust. And you in TV land might be able to, no. Oh, that's because your camera's too low. I gotta get you back at eye level here. And what do we got? No. No. It's a little finicky game we have to play here. I think it's pretty good. All right, I don't think I'm gonna get much better. Okay, so this is our spring B. Now, I don't know the spring. I'm just like blind doing this. So I'm gonna hang. Well, I do know a lot. I'm pulling on it. I can tell it's gonna take way more force. Okay, look what happened. Oh, well, it's now not focusing. Why does it do that? Okay, I'm gonna bring it out and bring it in. All right, can you see how much it moved? Yeah, there you go. That ain't gonna work, is it? All right, so we have to play some games with this one, right? So I'm gonna try 40. Woo! We may be switching springs. This may be trouble. I'm gonna try 50. All right, I think we got nothing. All right, I got a little bit with 100. We're gonna see. We may, I think we may need to switch springs here. Because it ain't much, is it? All right. Let me try 150. All right, I'm getting somewhere. Let me stop the movement. So this is 150. Here, I'll pull back so you can see. That weight's rolling away on me. Okay. Okay. So that was 150. So now I'm gonna hand and put another 50 on it. So I'm gonna go, I'm obviously have chosen an increment of 50s and seeing if we can make something happen here. Okay. All right, well, it's moving, so. But this crazy is gonna look, right? Sorry, I was trying to stop that bounce for you. Well, I didn't help it at all. All right. Do your best bouncy bounce reading on that. All right, so that was 200 grams. It had 100 and 250s hanging on it. Okay. So, I need another 100. Uh-oh. Do I have another one? Yes, I do. Okay. All right, that's 100. Just making sure I don't want to screw things up. So we just did 200, so this is 250. Oh, we're gonna start dropping now it's gonna start mattering. Yeah, it looks good. Okay. Okay. That was 250. Do I have another? Oh, I have another 50 here. So that's 250. Drop down a little, make sure I'm at level a little bit more. Okay. I'm gonna scoot this back a little so it's a little closer to point. See, my pointer has kind of started rotating on me. I'm gonna try to make it so you can, so the pointer really is pointing. Okay. So that was 2 100s and 250s on there. Ooh. I gotta dig out another set. More weights. Okay, let me get out another 50 here. It's getting a little crowded. It's getting a little crowded here. It's kind of fun. Drop my camera. Try to look again. I'm looking to see where the lens of the camera is lined up. Okay. Okay. So, all right, that was that crazy fast right there. don't I have, oh, that's what I'm missing, hold on. So let me take all this mess off and put a 200. I forgot I had a 200. I thought I went straight to 500. So I can do two 200s, yeah? Okay, just making sure. So this is a 200. Drop this, see? Another 200. All right. Make sure, camera, drop it just a touch more. Get you a little closer. This behind. All right. You see that? Yeah. Okay, throw a 50 on there. All right, again, drop this just a bit. And hold the paper. Okay. All right. Let me just add another 50. Since I got it, I could switch out to my 500, but why when I can have a party down there of all my weights? Okay, trying to slow it down a bit. Drop my camera a bit. Every time I'm looking from one side of the camera to the other to see that alignment. Okay, not bad. Okay. All right. All right, and just because I have it, because I got three weight sets here, so I'm just gonna go crazy there. Look at that. That's pretty funny, isn't it? Okay. All right, it's fairly entertaining. Pretty straightforward lab. It's good, except for like I said, when you graph it, things aren't perfect for a while. It makes people a bit crazy. In fact, you many times can consider the first piece of data an outlier, if not two. If it's crazy, then yeah, don't use your first and second data point to try to make your graph a straight line. This should be linear. Okay, so that was 550 with all that crazy crap in there. Okay, all right, so that's that part, and then you're going to calculate your spring constant for both. Now, from my experience, this is what I know. I know that, let me raise the camera a little. I know that the first spring generally, because like this little weird that it was really hard to get going at first, that the first spring is a little bit more uniform in its K value. From past experience, I seem to remember this. So I'm going to test my unknown with spring A. I could do both. Actually, maybe, so let me do B. Let me throw B. I don't know how much is gonna move with this. This is my unknown. We have unknown number 6. And I'm gonna hang it from the spring and with this, yeah, okay. All right. So there's not much point, okay? It ain't moving, so it's not enough. So that's not even gonna be, it's not even feasible. Some people might have springs at their lab table that's feasible. That wasn't feasible. Okay, so we're left with the first spring. Be able to just, I'm gonna flip this just so the pointer is a little easier to read. I need to reset this, right? Recalibrate this to 0 since, stop swinging. Okay. You have to close one eye when you do this in person, right? Because your two eyes are not necessarily at the same level if your head's sideways. All right. Oh, the reason you can't see it doesn't make any sense because you see really how important it is to have this at the right height. Okay, come on, focus. It's not focusing now. Hold on. Let me bring it out, bring it in. Okay, now it wants to focus. Let me rotate that pointer. All right, not bad. Actually, Can I move the pointer? Oh, I can shift that pointer. Instead of, I don't know. Let's see. No, that just ruined it. Sorry, guys. This is very typical of physics labs, right? They're very it's just a lot of like zhuzhing and moving things a little bit. Okay, that looks pretty good. All right, so I'm gonna move this back so you can see again. This is I'm not even sure of the material. I normally hide that information so students can't like use volume to find out the mass of it and density if they know the material. Okay, and you see, back it out, you can see it hanging and how much it has stretched the spring. I'm gonna have to bring, whoops, I don't know what I'm thinking. Not that far down. Okay, checking alignment. Okay, stop the bounce. Okay. Okay, and so you're gonna read that. Okay, and record. This is for part 2, determining an unknown mass, and you record the unknown number, which was number 6, and then you recorded how far the x distance. Actually, I don't think I even put a little spot for that, so just put that in that information, and then show your work on calculating the experimental mass, okay? And remember, don't forget, there's a difference between mass and force, and so careful that I asked for mass, okay? All right, so that's pretty much it. So again, for the lab, you're gonna solve for your Ks, then I included graph paper. You are going to graph, make a best fit line. So remember, this is experimental data. Experimental data, it's not perfect, right? So we're not gonna play connect the dots. We're gonna see the position of the dots. We're gonna take a ruler, it should be a straight line, and you're gonna position that ruler so that you have just as many points above the line as below the line to make it a good best fit line, all right? And then draw that line, and then I ask you to find the slope of that line because we are graphing f versus x, and if you have f versus x, then the slope of the line will be your k value. So that's the second way we're gonna calculate k, all right? So it should be kind of close. It can differ a little bit from your average. So on the front, you're taking all your k's and finding an average, add them up and divide by the amount. Again, you can ignore the outliers. And then here, again, you're gonna find the slope of the line, not of 2 data points, unless those 2 data points fell exactly on your line. I'm gonna look, okay? I don't want the slope of the data points. We've already done that. We want to, the reason for making a graph is to kind of average out all the errors involved and get a better value of our experimental data, from our experimental data. Okay, and then there's just a few questions on the back to finish up. All right, okay, all right. So hope you enjoy this